Okay, guys, I'm going to start now. My name is Nicholas. I'm representing NUS Game Development Group to teach you how to use Unity. So, first thing I want you to do is go to the slides because I'll be referring to the slides as I do the live coding. So, for the first slide, hang on. Let's go to the assign URL and you can see this. So, just a show of hands, who's used Unity before? No, okay. So, who knows how to code, or who has some programming background at the very least? Okay. Okay. I will try to make this as simple as possible, and so let's just see what Unity is. It's a cross-platform game engine developed by Unity Technologies, and it's primarily used to develop both 3D and 2D video games. So, if you all know about game development, another engine is Unreal Engine, and Unreal Engine is catered more for the 3D games. But for Unity, they offer support for both 3D and 2D games. So if you are planning to do a 2D game, you should be looking for Unity. So why do we use Unity? One thing, it's easy to learn. It has great documentation, and it's mostly free. The paid versions of Unity, you only need to pay for Unity only if you make a certain amount of profit from your games. But for something like Orbital, it'll be quite suitable because you don't have to pay. And also, lastly, as wide platform support. In Unity, you can export to various platforms for console, PC, mobile, and this is one of the big features of Unity. And also, if you all notice, there are 3 games over here. These 3 games are rather popular, and they are all written in Unity. So for the top right-hand corner, it's Cuphead. Bottom right, Monument Valley. Bottom left is Hearthstone. So let's begin by making a simple game. So the schedule for today will be, we'll do a simple controller. We go for lunch. After that, we do bullet spawn, and make a game manager. So the game that I'm actually making is this kind of bullet hell kind of game, where there'll be bullets coming out from spawn positions denoted by these triangles. And your job as the player will be to control your slime that you just made and avoid all these red bullets for as long as possible. So let's begin. Okay, I assume all of you have installed Unity. Okay, so let's just start here. Go to projects and we create a new project. And we call it whatever you want. But for this, I'll call it. Make sure your template is, wait, no 2D. Make sure your template is 2D. And then you can just create your project. So while this is loading, let me go through some key concepts in Unity. In Unity, how they model the game is that every object in your game is a game object. And if you want to add any sort of behavior to your objects, let's say movement, physics, audio, you add components onto your game object. So imagine this, like in your game, you have a player, he'll be a game object. You want a light shining in that direction, it is also a separate game object. If you want things like game managers where they control the game logic, like, oh, you lose or you get a bonus, it's also inside a game object. So this is one thing you need to keep, everything I'll be talking about are game objects. So let's head over to the Unity editor. Do you all see this screen? if you all open Unity. So in order to navigate Unity, we need to understand how all these work. So the first thing I'd like you all to see is this window here. It's called the scene view. It's where all your it shows the scene and it shows all the game objects in your scene. So in a game, you run a scene that contains game objects. Okay. The window on the left is the hierarchy. It contains a list of all your game objects and their relations to each other. So for example, I have a game object here, and then I want to put it as a child of this other game object. It will show. Let me just give you a demo. So I created two game objects and I set it as a child. So this game object is a child of this other game object. If I want to take it out, I can just drag it out. On the right hand side is the inspector. It will show all the components attached to the game object you have selected in the hierarchy. Okay. So for example, I click on the main camera. The main camera is this little camera icon here. So for the main camera, there'll be a transform. Transform is a component that contains the position, rotation, and scale of a game object. And all game objects will have this. The next component is the camera component, which contains logic for handling camera and showing your game on the screen. So we'll be working very closely with these windows to add behavior to your game objects and your players. On the bottom left here is the project window. It contains all the files in your project and anything from game objects, not game objects, sorry, scenes, scripts, assets. You'll be putting them in this folder. However, in your Unity project, let me show you. No, documents. So this is actually what your project view is seeing, but there are other hidden things that you won't see. Like for example, over here, every folder has a .meta file. Please do not delete this. This is very important for the editor to know the various references between your game objects and your assets. So when you are working with things like version control like Git, don't delete meta files. Always commit your meta files. But if you don't understand that now, don't worry. Just make sure you don't delete them. That's the most important thing. All right, everyone okay so far? Okay, so let's start making a basic player in our game. And as always, I was mentioning, a player has to be a game object. So let's start by creating a game object here. Right-click on the hierarchy window and create empty. And then we name it in the inspector player. And make sure you hit enter, if not it won't save. Next, I want you all to click on the player and add this thing called a Sprite Render. So how do you add components to game objects? In the inspector, there's this button over here called Add Component. You click on it, and then you get a search bar, which helps you find whatever component you want. So I want a Sprite Render. I just type Sprite Render. This component now allows you to attach sprites to your game object. So we'll attach the sprite later, but I'll just put a dummy sprite first. Yeah, you don't have to follow this part yet. Okay, so I created a sprite and put the sprite onto the game object. So this is the game object, and it has a sprite. And one thing you should know that on the top left-hand corner, there are a few tools over here. This will let you control your scene view, and if you want to move your your game object around, you click the second one, which is this cross thing, and it will give you these two axes for you to move your game object around. And a quick tip is that these buttons over here actually map to QWERTY, QWERTY. So if let's say I want to rotate, I just press E, and then I'll get that too. If I want to go back to this one, it's W. Okay, so now, so let's start off by creating our first script. To create a script, we create it in the project window over here. So right click, create C# script, and name it player controller. So when you create a new script, what actually happens is that you're actually making a component that can be attached onto a game object. So right now, since we have already created this file, we can actually attach this player controller over here, and it will run the script, and I'll get more into that later. But basically, you have now attached a behavior onto this game object, and now we're going to modify the behavior to suit our needs, which is movement. So now let's open the C# script, and there'll be an ID that will open up. The default one should be either Visual Studio or Mono Develop. And I'm not Carl. Okay. Okay. Was it too bright? Oh wow. Didn't even do anything. Okay, so everyone okay? Have you all reached this page, or at the very least caught up? So for those who don't really know code, I'll just give a brief overview of how Unity works. So in Unity, all the scripts that you want to add to your objects as components will inherit, which is this column, from mono behavior. So what this does is that specific functions will be called by the game engine, and then we will, in our script, we will respond to these functions. So one of these functions will be update. So what happens is that the game engine, every frame, it will call this function. So from the script's perspective, he will just write whatever he wants to call in that update function. So for example, I want to move every frame, something like that. So all I have to do is just write code for movement, and attach this player controller to the game object, and then it will execute this code that you wrote every frame. And this will be the frame rate of your game, based on the frame rate of your game. So that's update. Another function will be start. So every time you hit play in your game, and this component is loaded into your game, it will call start. And you normally use this for initializing variables that you want to. Okay, so let's start writing code for the movement. And if you are following the slides, the code is already there. You can just copy and paste, but I'm just going to quickly do a run through. So first thing for movement, I want to create a float. A float is like a number that can have decimals, and I call it speed. And I'll give it a default value. So the speed of my character is 1 unit per second. Next, I will try, for every frame, I want to handle an input and then move the character based on the input's direction. So to read input, you can use this function. input dot get key. And then you give the key code W. Okay, so what this does is, in this frame, did the W key get pressed? If the W key get pressed, what do? We want to move up, right? So let's store this information in a vector. So a vector is like basically if you know some basic math, vector is like a direction, or it's from one point to another point in space. So let's say I want to point upwards, the vector will be 0, 1. So it's 1 unit up. So let's create a dummy vector first. So what this does is, first we set the direction to be 0. So nothing has happened yet. If we press the W key, we want to point the direction upwards. So we do direction, and then we add vector 2 dot up. Notice how I use vector 2 dot up. You can also do this. Create a new vector 0, 1. Exactly the same thing, but let's just use this for now. Okay. Now this is done. We can translate the character based in that direction. So, and then we need to know how much distance we need to move per frame. So we use this simple formula where get the translate distance is equals to direction times speed. Okay, so what this is actually is that some basic math is that if you are going up, it'll be 0, 1. Then we move in that speed, but we multiply by time dot delta time. Time dot delta time is the time between each frame. So if you multiply the speed and the time between each frame, you get the distance that you move, the exact distance you need to move between frames. If you don't understand that, we can just accept it for now. Right. And then next we take the transform of our game object, and we translate this. A lot of these functions are actually built into this mono behavior class. So it's just a matter of knowing what you can call, and for this kind of issues, you just have to check the Unity documentation. Or otherwise, if you do a few tutorials, you get the hang of what methods you can call within the class. So now that this is done, you can go back, and it should be able to only move upwards. So when I click play, it will bring me to the game view. Notice how it changed from the scene to the game. And if I click W, it moves. Yay. Okay. But if I click other buttons like A, S, D, it doesn't work because we haven't written code to handle these other inputs. So let's just do it there. So now we're handling for multiple inputs, and then we add the direction of the input accordingly. So let's say if I press S, I'm going down. So I just change this to down. If I press A, I'm going left. There I put left, vector 2 dot left. If I press D, I'm going right. right? And the last thing to make this work is you have to normalize the vector, which is just making the length of the vector 1. And everyone okay so far? Are you all following? All okay, Anything, just scream. Okay. Oh yeah, by the way, this code is all on the slide. So you can just grab it, paste it there. No problem. All right. Okay, let's see what happens if I don't normalize, right? Okay. If now if I start moving around, I move in two directions. Let's say A and S. I actually move faster. So we normalize it so that we change the vector into a unit vector. So it's just a directional vector, and there's no additional magnitude applied to your speed. That's why we normalize it. But I know some games, right? If you surf in the air, you can accelerate or something like that. Yeah, maybe because of this, never attend this workshop. But all right. So let's see this in action. Now the speed is not so bad. Yeah, another thing I want to highlight over here is that there's one difference that I have between what I wrote and the one on the slides. Notice how in the slides there's no public field in front of the speed, but for this I do. And if you set this to public, what actually happens also is that in the component itself, you can edit this value in the editor. So let me just show you. Seeing that this is a public value, I can now edit this value in the editor. And when I click play, it will use the new value. So as I'm playing, I can, like, when I'm play testing, I'll be changing the speed around, and then, whoa, it's faster now. But just take note that once you stop hitting play, it will go back to the original value. So you just have to take note of that. But this is pretty useful for play testing. And for those, let's say you're working with a designer, like in normal game development, you'll be working as a programmer, designer, artist. So if you're a programmer, you want to expose some variables to the designer. So you try to do such things so that the designer will have a much easier time. Because not every designer will have some coding background. So just doing things like this will make life a lot easier for them. Okay, all good, all good. Okay. Now let's add the sprite to your player component. And this sprite is actually the sprite that you just made if you actually made a sprite during the physical workshop. But if you don't have a sprite, you can just go to the Slack. I've posted a zip folder, a zip file for the slime that I'm going to be using, and I have it already downloaded. So if you want to import an asset outside of Unity, you need to import it like this. You click Assets, and you click Import New Asset here. And okay, you should have this image. I'm going to import it. This is the sprite sheet that we exported from the physical workshop. So when I import it, it'll be inside my project view. But this is not usable. As you can see, it's just two slimes stacked onto each other. We need to process it further so that we can use the slimes individually. So let me show you how to do it. So let's delete this first. Click on this sprite. Everyone has this sprite already. You click on the sprite, change the sprite mode to multiple, and then you click apply. That's one of the steps. The second step is to open the sprite editor, and we need to slice the spreadsheet. So in Unity, the sprite editor is pretty powerful. It can actually automatically slice up the sprites that you made. Slice up the spreadsheet that you made, sorry. So just on the top left-hand corner, there's a slice, and then type use automatic, which is leveraging on Unity's slicing, and then we just click slice, and then notice how now we have two sprites over here that have been sliced, and all we got to do now is just click apply, and we have successfully sliced our spreadsheet. And over here you can see now there are two different sprites. And knowing that this is a sprite now, we can actually replace this square that I put originally with our sprite. So put it here. Okay, I misclicked. Now we have a sprite, the slime sprite in our game, and it can move around. Okay, this is quite slow. Okay, all good. Any questions so far? Just a question, am I going too fast? Anyone can reply? Okay, okay. Okay, I'll just continue now. So you notice that one problem that we have is that when we move left and right, the sprite doesn't flip, and so this sprite can actually walk backwards. So ideally, what we want to do is for the sprite to flip every time we change direction. So this can be done in our script, and notice in our sprite render over here, there's this flip X and Y. So what the idea now is that every time we are moving to the left, we flip the sprite in the X direction, which is vertically here, right? Or horizontally. Okay, whatever, never mind. So when we move to the right, we just set this value back to false. So let's do that programmatically. And then the next question is, how do we get the sprite render into the layer controller? So the first thing we need to do is get the sprite render, a reference to the sprite render in our layer controller. This is a private reference to the sprite, and when the game, when we want to get that sprite render, we need to use some functions in Unity to gain a reference of that sprite renderer component for that game object. So over here, when our script starts, we can use this get component. And sorry. So basically what this does is I'm just saying that I want this component of type sprite render. And this means that in my current game object, I want a sprite renderer component and I want a reference to it. And now I'll assign this reference to this this value sprite. So to recap what's going on in this view, from the player controller, when it gets loaded, over here, if you can see my mouse, it will check the game object. The game object will see that I want this sprite render component. this component that's inside of me. So it will grab this sprite renderer and pass it to the player controller. Okay. Hope that makes sense. So once this is done, we can just simply set the flip x, this value over here, the x value, to true or false whenever we want to. So now when we are moving to the left, we can do a sprite dot flip x true. And if we are moving to the right, set to false. Okay, so now when oh, what happened? Yeah, as a side note, so every time you change your script, right, Unity has to compile your C#. So on the bottom right, there will be a small little loader. So don't just click play after you save. Just wait for the loader to finish, then you click play. So now, when I move left, it flips. When I move right, it unflips back. So now we have this movement. Okay, so in the physical workshop, we actually we made another sprite over here so that we can create an animation for movement. So let's create an animation and play it when we move. So the first step in all of this is to create an animation controller. So in your project view, you right click here, create, and you find Animator controller. You click, and you can name it whatever you want. I'll name it player. So I've created this, but we can ignore it for now. We go to player, and we add this component called Animator. So this Animator lets you add animations to your game object. So you see how this works is if you want more behavior, you just keep adding components, add components to that game object. So in the future, let's say you want to add audio, we also create another component on the object. If you want more logic, add component. This is the idea. Next, we take our player animator controller and we drag it into this controller component here. So what this animator controller actually is a state machine. And how Unity handles animations is that when you want to play a new animation, we need to go to a different state in the state machine, and you'll see more later. But the current, when you double click this, you see that there's no states right now. So when your player is not moving, it should have an idle state. So let's create idle state with no animation first. So you just create state empty. And since this is the first state, it will become the entry state. So every time this controller starts, it will automatically go into this state. And we can rename it over here in the inspector, IO. So this wouldn't have any animations, it's just an idle animation. And ideally, what we want to do next is to make a transition into a move animation, but we need to make that animation now. So very important, while clicking onto player, just make sure your player is selected. Let me open a new window, and we get this animation window, and you should get a pop-up, and you can also drag it into the editor like this. I like to put it here. So again, very important, make sure you select player, and then to begin animating player, create an animation clip, you click create. and we are creating a new animation, and we are calling it move. So now we have this new animation, but with with nothing actually, no sprites. So what we need to do is to drag the sprites into the animation, and we need to make sure we can see the project view like this. Okay. Now, but clicking while holding Shift, click on both sprites and drag it into this animation here. And now the animation should be done. And when we click play, okay, it's really fast. But the idea is that you now can animate your character to do this bobbing animation. And to reduce the speed, just reduce the sample count to something like 5. Now it will be slower. So it's playing at 5 frames per second. So it's quite cute, and we just need to connect the pieces together, right? As I was explaining. So notice how there's this new move state. Just take note, this is not an animation, this is a move state. The animation is actually in this motion here, right? So I can just call this anything I want, doesn't matter, it will still play this move, but let's just not do that, right? Okay, so in order to go into this new state, we need to have an edge to that state. So or rather like a transition or path to that state. So while holding onto idle, clicking onto idle, right click, make transition, and then you have this arrow thing, and drag it and click it onto the move state. So now what this means is that you can now transition to your move animation. And then likewise, we can always stop in your game to make a transition from move to idle. So when we animate now, when we want to move, all we got to do is just make sure we can cross this transition into the move state, and we are done. So how do we do that? So notice over here, there's this condition. This condition means that whenever it's fulfilled, I will go through this transition into the other state. And there's right now there are no conditions because we need to have some parameters to decide whether we are going to cross that transition. And what we're going to do now, over here on the left hand side, if you can see my mouse, click parameters, and we're going to create a new parameter which will be our condition. We're going to use a bool. A bool is like a true or false, if you are not familiar. So we're going to call it is moving, right? So the idea here is that when I'm idle and then I want to move, I will set is moving to true, and it will cross into the move state. So in the transition here, under the conditions, we add a new condition. So what this means is, if I'm idle and I'm moving, I want to go into the move state. So that's one thing. Now, if I'm from the move state and I'm stop moving, then I want to go back to the idle state. So I set another condition here to false. All right. Okay, and I think that should be enough for this animator component for now. Now all we got to do is, in our script, we just make sure somehow that we can change this moving, right? Because if you can see, let me drag it here. When I play the game, notice how it's idle here, and then when I click, it's moving. Oh, it starts moving, and then when when I click, it's moving to be false. It stops moving. So now we have this sort of interface. All we got to do in our script is just set this is moving to false or true whenever we want to, and then it will just play the animation for us. So let's go back to code, and So the idea is you want to be able to access that animator. So we want to get this component in our player here. We want to grab this animator component the same way we do for the sprite. So we create a reference to this animator. We call it anim, and in the same way we do this. Now for the anim, all we have to do now is set the Boolean value of is moving to true when we're moving and false if we're not moving. So how do we know if we're moving? We are moving only if the direction is 0, right? So if direction dot, okay, we can just do this first. If we're not moving at all, means you see how direction is a 0 vector. If we don't press anything, we're not moving, right? So if we're not moving, we pick the animator, we set the Boolean value, we set that parameter, and the parameter's name is moving. We set it to false. Else, we set it to true. If the direction is not 0, it means we're already moving, so we can set it to true. Alright, it should work. So now when I go back to the game and I click play, so if I click S, okay, I have to click on the game view. Okay, there's some delay when I move. Notice how there's like a short delay when I go from an idle state to the move state. The reason for this is because of the exit times of the state. But to resolve this, just click on the transition here. Has exit time, turn it off. And for the other one as well, has exit time, turn it off. And for this thing, you just squash it if you want to. This one you can go and read up, I guess. But now there's no delay, and our slime can move. All right. So basically, we are kind of done with our player, and we have set. So what we have done is add add movement, add animation, and notice how I'm using this translate logic over here, meaning I'm actually moving the game object manually, like translating it directly. But in Unity, there are other ways to move your character around. You can actually use Unity's inbuilt physics to move your character around, and you can go and read up. I've put a slide on that slides page, and you can read up on using physics to move the character around and also handle the various differences when you're dealing with Unity physics, because Unity physics is actually a bit tricky to handle. So if you are not really familiar with Unity, you may make some mistakes and there will be some bugs with your code. I've experienced a few bugs where, like for example, if I try to translate my character and suddenly it clips into the wall for some reason and then he just goes through. So there are some small details. If you are feeling up to it, you can go and read up on that. So actually, the plan now is to have lunch, right? But any questions? Who's actually doing the project as I'm doing it? You're okay? Okay, right. Very good. Uh, any questions so far? If not, I think we have time. Maybe we start working on the bullet logic. Okay. So if we are not on the same page already, I'm at slide 29 of the Google Slides. We are going to do some bullets for our game. So like always, when we want to create a new entity in our game, we need to create a new game object, right? So we create an empty one here. So this is our new game object. And we name it bullet. And if you want to see things, we add a sprite render onto it. And we are going to add a sprite, a circular sprite, a circle onto it. And to just now I showed you how to do the square. To create a circle, you just right click, create, sprites, circle. And then, yeah. So we have a circle now, a circle sprite that we can now drag into the sprite render for a bullet. And also just take some time if you want, you can play around with these values on the component. So for the color, we can click on this thing directly and we can just change the color to however we want. Let's use red because why not? Use red. Okay, now notice how the bullet is a bit big. So if we want to scale down the bullet, what we can do is actually change the scale in the transform. Remember how every game object has a transform? So in the transform, there are a few things that it records down. The position, rotation, and scale. What I'm interested in now is the scale. We can reduce the scale to reduce the size of the game object. So let's reduce it by setting the x and y to 0.5 or 5. So now our game object is much smaller, right? Okay, now the next step we want to do is translate the bullet, like how we translate this slime character, but we don't want to read inputs. We just want to keep translating it every frame. So remember how we want to, if you want to add behavior to a game object, we create a C# script, right? So let's create a new C# script and we call it bullet behavior. And we can open it in the editor. Oh yeah, for those using Visual Studio, if you do Control K, then you do Control D, it will actually auto indent your code for you. Yeah. Just a quick tip. And notice how like it's, if I'm not wrong, right, for those who are in School of Computing, the people like to put the brace over there. But for C#, the common convention is to put the brace one line below. Yeah. So that's why it auto indents to this. All right. So maybe as a small little exercise for those who are doing the project as I'm speaking, I want you all to translate the bullet in the downward direction every frame based on a speed that you specify. So the key here is like you need to understand what this code does, and you can actually copy and paste code into the bullet behavior, and you should be able to achieve this. Maybe I'll give you all like 5 minutes to get it working. And for the rest, let me see. For the rest, I'll just quickly show you. Have 5 minutes. But for those who are not doing the project, y'all can just check it out. It's actually pretty similar to what we wrote for the player controller. Basically, every frame we move the bullet in the downward direction by a certain distance calculated by this line. Yeah, and then we just translate it. So we calculate the distance, then we translate. Okay, right. You have a question? Yeah, no problem.
This one, right? How do I get to this part?
Oh, wait, what do you want to do now?
I want to add a sprite sheet.
Oh, have you created the player? Oh, you want to create it? Okay, go assets. Sorry. Go assets.
Oh, okay.
Then import new asset.
But I thought here already is all the
But what do you want to do? Actually, you want to import the sprite sheet? Or you
I want to import the sprite sheet.
Import the sprite sheet, renderer.
Sure.
Oh, this is not a sprite sheet. This is a script.
Oh, this is a script.
A script. You want to import the script?
Oh, sprite sheet. Okay.
Okay, what do you want to do now?
Because I created a script. Is it attached the script?
Oh, okay. Okay, you go back to your editor. Unity. Actually, how is it called new behavior? But it's okay. It's okay. You click the add component.
Yeah.
So now you can search for your script here. So I think it's called new behavior.
Oh,
you have to use that.
Okay.
Do you try using player and then you couldn't find it?
No, cause over here they never say go to player.
Oh yeah, cause I want to let you.
Okay.
Okay, yeah. Just make sure when you create a script, right, you quickly name it. You name it, then you press enter, then you can't change the name anymore.
Okay.
So that's why it's called new behavior script forever.
Oh.
But then you can just recreate a new one. It's no problem.
Okay.
Yeah. Yes. Yeah, no problem.
How do you actually?
Oh.
I don't have any sprites for this.
Yeah, no problem. Yeah, what do you do?
Yeah, how do you actually make it move? Because I put the script, you just say attach the script to the player, right?
Yes.
So I attach it already, but then when I play it, it doesn't move.
WASD. Oh.
Yeah.
Okay, can I see your script? Can I go all the way down? Go back up again. Okay, let's go back to the original. Yeah, click on here.
It should be moving, right?
Let's play again. What's the reason? It only records WASD. Click on this screen. Okay, hang on. Give me a moment. should be quite simple to fix. Hmm. This is weird.
Also, how much you can do the scale because I'm not only transforming about bigger.
Okay, so you just have to change the X and Y to whatever scale you want. So let's say I want to double it.
But I can't seem to pick it.
Oh, could this be something like a slot? Yeah, why can't you could this? Hold on. But I can.
Should I do it
Okay.
again?
You can try, but okay, if you cannot, I'll during lunch break I'll go and help you. Okay. Okay, guys, back to Earth. So everyone okay with this? So if you go back to the game and you click on your bullet game object, we can now add the bullet behavior onto your bullet, and it should move down every frame, like so. And wait. Notice how I've added a public speed, so you can always increase the speed for your own testing. So now we managed to add a bullet, but the bullet doesn't kill the player. The reason is because we haven't. One thing is we haven't written a script for it. Another thing is we have not added behavior for collision in our game. So in collision in collision in Unity, we are using the Unity physics. Not Unity physics, but using just basic colliders. And then every time, how colliders work is that every time you overlap with each other or you hit each other, the involved parties will be informed that they were hit, and then from there, if you know you're being hit, what do you do next? That's the idea, basically. So to illustrate, this will make a bit more sense when I start writing logic here. So the first thing you need to do is to add your colliders onto your game objects. So for two objects to collide, you need to have both parties to have a collider. So for the bullet, we are going to use a circle collider. So you can add a new component, like everything is a component. So circle collider 2D, enter, and you notice how there's a green outline. If I turn this off, it's no more. So this is the collider, and you can think of it as like it's like a region of space that that can overlap with other things, and it will detect collision. For the player, we are going to add a box collider. Okay. Now our little slime is in a box, but ideally, in some games, right, there are some parts of the character that cannot be collided with for obvious reasons. So things like this I don't know what you call this antenna, right? You wouldn't want it to be in the collider. So what we can do is, while clicking on this player, we go to the box collider component and we click this edit collider, and now we can drag around like so, and let's just make the little circle his hitbox. All right. Okay. On another note, I also need you all to add this thing called rigid body 2D. So rigid body 2D is required for this whole setup to work. I'll explain in a minute why it's important, but right now just add it in first, and make sure your body type is set to kinematic. So if you set it to kinematic, TLDR, it means that it's not affected by forces. Because what we are doing right now is we're just translating the object directly. We are not applying any force to this character. So just we'll set the body type here to kinematic, and it's more efficient as well. So that's another important thing to take note. Okay, so now the idea now is we're going to have the bullet collide with the box collider, and when the bullet collides with this box collider, we want the bullet to destroy the slime, right? So the key thing here is we want the bullet to do it. So the code that we are going to write will be in bullet behavior. And another thing that we need to know is how do we know if it collides? So there's this function in mono behavior, which is this thing that all of these scripts that we write inherit from mono behavior, and mono behavior has this function, and it's called on trigger enter 2D. So let's break it down. On trigger means that when a collider enters a trigger, and for a collider enter a trigger, we need to set this circle collider to be its trigger. So on trigger enter 2D, when a collider enters my trigger, a trigger is something like when something enters its space, it will be informed. You can think of it that way. So from the bullet's perspective, when someone enters my trigger area, my collider, the game object mono behavior will tell you that someone entered, and whatever entered is they will pass you the collider of the other object. So the signature of or rather the how you write it is when we define this function on trigger enter 2D. Don't like this word, let's just call it collider. Okay, so every time another collider enters my trigger, the Unity will just pass me the collider of the other game object. So this is how we work with this kind of function. So knowing that I'm going to receive this new collider, now I will be able to do various things to it. For example, I can destroy it, or I can add additional behaviors to it. But for now, we are going to destroy it. So over here, just to recap one more time, when this slime enters this red trigger zone, the script in this bullet will be informed that the slime entered his zone, and then he'll also be informed of what the collider is, and which is this thing, right? So now the simple thing will be to destroy it, right? And then we also destroy the bullet. Will make sense, right? So when the collider comes in, when something enters, I just destroy it regardless of whatever it is. So remember how I talked about this player requiring to have rigid body. Okay, loading. Rigid body. The reason why you need this is because if either colliders do not have a rigid body, this on trigger enter 2D will not be called. So the requirement is that one of these colliders needs to have a rigid body 2D. So we just put it on the player, right? This can be found in the Unity documentation. I do not know why it's like that, but it's just how it is. For trigger events to be sent, you need at least one of them to have a rigid body 2D, right? The collider? Which collider are you referring to? Yes. Yeah, you can put it on the slime, then the slime. Now the responsibility is on the slime to destroy itself, and then the slime will also destroy the bullet. But it's the same thing, yeah. But that's a good point. In game development, right? You can design however you want in terms of code. Like as long as the end result looks like how you want it to be, it's fine, right? But there are always good practices to follow. But I won't cover that today. But the key thing is you need to know your way around this engine so that you can achieve the result that you want. So indeed, there are multiple ways to do things in Unity, and this is one thing. Okay, so another thing I'd like to show you is how to print statements onto the Unity engine. So you guys write Java or something, like you all use println, right? System.out the println, but for Unity we use debug.log, and then okay, debug.log, and we hit, right? Okay, and let's go test it out and see if the slime can get hit. So on the bottom left, you should notice this thing called console. This is where all your debug statements will be printed out. So when I click play, okay, do you notice something? That the bullet stops moving, but it's not destroyed. Anyone knows the reason why? Because over here, I did try to destroy it, right? But we need to know what we are trying to destroy. So over here, for both things, over here I'm just destroying the collider component, and over here in this I'm only destroying the bullet behavior component. So if I go back into this, notice that the bullet has no more bullet behavior anymore, and notice how the player has no collider component anymore. So that the key thing here is we need this collider is actually the component, but it's not the game object itself. And this is a common mistake made by a lot of new developers. So what we need to do is actually destroy the whole entity, which is the game object itself. So we just call game object. Collider, there is game object, destroy. Here, we can also do it the same way. Bullet behavior has a game object. It's attached to the game object, and we can just get the game object like so. And for shorthand, we don't need this. And this should work. So if I click save and I restart the game, see, now we are destroying both the game objects. Notice in the hierarchy over here, the game objects are gone. And this is the behavior that we want. But just another thing to take note is this is doing destroy.this, like so. It's not always wrong, right? Because for example, like okay, let's use an example like Mario, right? Mario has this fire power up, the one that spits the fire, or whatever you call it. If I get hit, I transform down into the big Mario, right? So in a sense, instead of destroying the Mario itself, we destroy the fire power up, right? So if the fire power up is a component on itself, we can just call destroy.this instead of the game object. So you just the key thing again is know what you're doing and work your way around the code to achieve what you want, right? Okay. Okay, guys. I'm gonna start the workshop again, and we are going to continue from slide 33. On the slides, if you all forgot, that's the link to the tiny URL. To the slides is a tiny URL. So let's do a quick recap of what we have done so far. The first thing is we made our character move, and then we also we made our character move. We flipped the character, we added animations, and we also added the bullet which kills the character like that. So what we need to do now is to create the spawner for this bullets. Because in the end, what we want to achieve is something like this, where the bullet is spawned from these multiple spawn points, and you as the player, you have to dodge and survive for as long as possible. So the first question that we need to ask ourselves is, how do we spawn a copy of another game object? Because this bullet only exists as one bullet in the scene, right? So if we want to spew out copies of this bullet, what we can do now is create what is called a prefab. So what I want you guys to do now is click right click here, create prefab, and call it bullet. So a prefab is an asset that lets you store a copy of a game object's components and properties. So in a sense, it's basically a blueprint or a copy of your game object. And in order to copy the properties, what we do is we drag the game object from the scene into the prefab like this. Okay, repeat that. And you copy every single thing into it. So now this is a bullet prefab with all the behaviors that we have defined previously on this game object. And we can just drag it in, and we can like spam them here for you. Okay. So this is the basis of how we are going to spawn multiple copies of the bullet. Now the next thing is we need to create a spawner that helps us spawn these game objects. So what I want you guys to do now is create a new game object and call it spawner. And this will be an empty game object that will be like hidden off screen. And the next thing you need to do is create the spawn locations for your bullets. So first create a new one and create multiple spawn locations. So I'll call this spawn location. Now give it a sprite render. And I want it to have that triangle, so I'll go create a new sprite like this. Right click, create sprites, triangle. And I should have a triangle here. And I take the triangle, I drag it into the spawn location sprite renderer. And since our bullet always moves down, I want the triangle to point downwards. So looking at the transform here, what we have to do is, we don't have to use the transform, sorry. We use the sprite renderer's flip Y to flip the sprite downwards, like this. So this is one spawn location, and we can copy multiple copies of them by using copy or Ctrl+C, and you paste. We have multiple spawn locations like this. So the question now, so the idea now is, as the spawner over here, I want to choose, like every certain amount of time, I want to choose one of these locations. I want to choose one of them, and using that location, I want to spawn a bullet. So this is the idea that we want to create, and using scripts we can do so. And to do this, we create a new C# script called bullet spawner. So right click in the project view, create C# script, bullet spawner. We open it up. So the first step we need to do is we need to have the spawner. By the way, you can just add it here first. We need this spawner to gather the information of these 4 locations. In order to do so, we can think of it like we want a list of these locations, right? So we can create a list of game objects. This will contain references to our spawn locations. So I'll call this spawn locations. And make sure it's public. Now, if we head back to the editor and wait for it to compile, you suddenly see this new field here. It's actually a list of size 0. And what we can do now is we can drag all of these locations into this list. So take this, drag it here. It will be added into this list, like so. So a quick tip is, you notice if I want to select multiple spawn locations, it will deselect, right, the other stuff. So what you can do is on the top right hand corner, there's this little, can you see it? Oh, there's this little lock. Oh, you can't see. There's this little lock here. So it locks the inspector in that view. So whenever you change your selection in the hierarchy, the inspector doesn't change. So now I can select spawn location 2 and 3, drag it and add it to this word, to the spawn locations. So this is how you reference other game objects into your script, multiple game objects into your script. Okay, now the next step is some basic game logic where we decide a random spawn location. So in each update, we want to select a random spawn location. So first we use a random index to decide. So this is just some C#. It's nothing to do with Unity yet. And we use .count because we don't use .length. I don't know why. So first thing, from 0 to the maximum length, we find a random index, and we get a reference to that game object. So this is a spawn location. Okay. So this is a random selection, one of these game objects. One of these 4 game objects, I'm choosing a random one. And from there, now I can decide to spawn my bullet. And in order to spawn the bullet, we need to have a copy of it, which is the bullet prefab I mentioned just now, right? So in order to get a reference to that, we create a new public reference for a game object for the bullet prefab. So a prefab is also a game object, but it has to be this cannot be something from your scene. It should be your prefab so that you can spawn multiple copies of. So okay, once that's done, you can see over here there will be a game object. Over here, the bullet prefab. We can drag this prefab in here, and now we have the copy of the bullet. We now have a reference to the copy of the bullet, and we can now spawn this bullet like this using instantiate. Instantiate this bullet prefab, and there are some other values here. This is your position of the game object, and this is the rotation. And okay, let's not comment it. So how do we get a position and rotation from a game object? Anyone remember? Yes, that's right. It's from the transform. Yes, and then so all we got to do now is get the transform, and then we can get the position, which is a vector 2. And rotation is a quaternion. All right. So if you all didn't get why the transform works, it's basically just setting the transform here, pick the rotation, plug it in, pick the position, plug it in. So the bullet will spawn at this location. So let's see if this works. Okay. Okay, now the reason why it's spawning so much. Anyone knows why? Yes, because this thing is on update. So every frame that your game runs, it will try to spawn a new bullet. So let's say your FPS suddenly drops. Like for example, you start lagging, then your FPS goes like 20 FPS. Then your bullet spawn rate will actually also slow down. So that's a thing to note how update works. So a common way to do a time interval is to use timestamps. So a timestamp is like after, like you're saying, if my current time is past this time, then I want to do the action, and then I set the next timestamp. So let me show you how to do it. Okay, I just remove this. So we create a float timestamp, and it will always, if you don't specify, it will be 0. So I'll just explicitly specify it. And if time.time is a time since the game started, and it's less than the timestamp. Sorry. And we return. If we have not reached the next, meaning if our time has not reached the next timestamp, we don't spawn a bullet. But if it has, it means it's time to spawn one bullet, and we need to update the timestamp as well. The timestamp for the next one. The timestamp equals time.time plus a certain delay that you want. So for example, 5 seconds. And okay, maybe we just put it as a value here. So okay. So what this means is every 5 seconds, I will spawn a bullet in one of these random positions here. Okay, you all can count 3. 1, 2, 3, 4, 5. Okay, it works. And then you can reduce the delay to, let's say, 2 seconds. So the next bullet will spawn. Now the bullets will spawn every 2 seconds. Right? Okay. So we have done the bullet spawn logic, and as an added bonus of the code that I've written, we are able to do things like this, where we can put the spawn here, and we can rotate it. So I'm using this button here on the top right. I'm using a shortcut E, and then I can rotate like this. And because of how I instantiated the bullet, and pray that this spawns here. Please. Okay, see now, notice how it's in the direction of your arrow, right? Anyone knows why this behavior is like that? Okay, maybe I didn't explain well enough, but basically you are instantiating the bullet with the spawn that triangles position and rotation. And since we rotated the bullet in that direction, it will always go down in that direction. Okay? So yeah, there are many other ways to do something like this, but you just have to either there's more than one way basically. So as long as it works, then the player is happy, right? So that's all you need to care about. When it works, then you're done. Okay. They're all okay? All right. So now let's try to resolve some issues regarding optimization. There's a problem with the game as of now. Let me try to demo it for you. So I can go to the scene view and still see this. Oh, the speeds are very slow though. Okay. Does anyone notice like any potential problems with this? Yes. So if you keep spawning bullets and don't stop, right? You realize that if your bullets spawn forever, and then and the game engine actually has to handle the logic for translating these bullets, even though they're out of your screen. So this can result in some slow gameplay if your player has managed to survive for that long, right? Which could be a good thing, but no, it's not a good thing. But anyway, so what we need to do now is to make sure that the bullets despawn when they have left the screen. There are multiple ways to do this. I can explain one. One is you for in each frame you just check whether the bullet is within the screen's position. That's one way. But for now, I'm just going to do a simple version where I'm going to create a collider here. And when this bullet hits the collider, it will despawn, right? And let's do this by creating a new empty game object, and we call it a wall. Because why not? And give it a box collider 2D component with a rigid body that is set to kinematic. Okay, by now you all should be quite fast with this. Now I want to extend it to the entire width of the screen. So I just increase the X scale by 20. And let's duplicate it. I didn't do it. Okay. Oh, sorry, I didn't save this value. We also do it for the height of the screen. Okay, so let's see whether it works. Okay, do you all notice that the ball actually destroys the wall? Let me replay it again. So the reason why this is because the bullet doesn't know what it's hitting, right? Currently, our bullet logic is that it will just destroy whatever it hits. So if we want to leverage on these colliders, we need to make sure that the bullet knows which collider is actually hitting. If it's the player, we kill it. If it's not the player, we don't destroy it, but we only destroy ourselves, right? So what we can do is actually set a tag on the game object. So for the player, click on player in the hierarchy view here. Under tag, you can select player. So now this particular game object will have the tag player, and you'll be able to check its tag by accessing the game object. And let me show you. So like the logic now is if I collide with something, I destroy myself, but now I want to check the other collider. That's not the bullet. I want to check the other guy. So if collider dot game object dot tag equals to only if the other guy is the player do I destroy the game object. Right? And let's see this now again. So it compiles. And to double check, yeah, okay, the player died. So now our bullet is aware of what who is it colliding with, and this will make sure that our bullets will despawn properly. So as a quick side note, normally you can do this equality like this, but something advised by Unity is to use this special function called compare tag, which will optimize the comparisons. But it doesn't really matter if you're doing a small game. But just for good practice, let's just do it now. And it should. Wait, I don't even need to reference the game object. Okay. Yeah, and it should work. Okay. Is this? Okay, can. All right. Okay, so now we have something that looks like a game, I guess. But what makes a game? What really makes a game is the challenge, right? So it cannot, and it's also a progressive challenge. So a game cannot be too hard at the beginning, but it cannot be too easy when the player gets used to it, right? So ideally, what we want to do is to increase the difficulty of the game as it goes longer. And for this kind of game, that's what we want to do. So the longer this slime can dodge all the red balls, the harder you want it to make it for the player. So in order to handle this kind of logic, we need to write another script. And this is normally done in a script called Game Manager. So the Game Manager will be in charge of all the different game logic that will be in that the game will be played, I guess. So one thing that a game manager can do is like decide what the level of the game is, and after a certain period of time, we'll increase the level, and this will in turn increase the difficulty of the game. So as with everything, we need to create a new game object, and I'm going to call it game manager. And this will not have anything. It should just be like a, like if you believe like a god there who will be monitoring the entire game, and it will just tell the game whether you need to be harder or easier, things like that. Next, I want to create a new C# script and call it game manager. And this, notice how it became a gear. There's a weird reason why it became a gear. I think there's like some special thing that when Unity sees game manager, it will automatically assign the script to a gear icon. But in a sense, it's actually the same thing. I'm not too sure why they want to assign this as a gear, but just take note. Don't be surprised. It's still a mono behavior. It's still a script that can be placed in the game object as a component. And that's what we're going to do now. We're going to write logic for the game manager. So at the start of the game, I want the level to be level 1. And after a certain period of time, I want the level to increase. So let's say every 5 seconds, I want my level to increase, and this will increase probably the speed and the number of bullets being spawned per second. So remember how we do handling of interval kind of thing? We're going to use timestamps again, and it's basically the same setup. Don't have to be public. Oh yeah, by the way, I have this convention where for public values, right, I put a capital in front. Then for private values, I use camel case. It's just a habit. So, and it's good to standardize things like this to make your code cleaner. Just a quick note. So this is the same setup as I did for the previous ones. And oh yeah, I need a delay too. So this is the basic setup that every 5 seconds I will execute the code below. So what I want to do every 5 seconds is just increase the level by 1. So let's go back to the game and make sure that the level increases accordingly. So under my game manager, I will attach the game manager script like this, and the level set to 1. And let's see if it increases every 5 seconds. Okay, notice how it became 2 at the beginning. I'll deal with that later. So, but just make sure 3, then we'll go into 4, 5 seconds later. Okay. So there's a reason why when I started the game, the level became 2 immediately. The reason is because if the time is less than timestamp, at the very beginning of the game, it's always false because your time will be 0 and your timestamp is 0. So you always increase at the start of the game. So normally to work around this, I will just set the timestamp to be the delay, and then there'll be another problem because you can't do this because this is a field in a class, so you need to make it static. Okay, if that didn't make sense, just accept, I guess, for now. But basically now I'll just set my timestamp to the delay, and so it should work. So now it always starts at level 1, and then it will increase to level 2. But the problem is now you also lose this static field, but it's a trade-off, I guess. Okay. Anyone got questions so far? I knew it was. Are you okay? How many of you are at this stage already? Wow, that's good. Am I going too fast for the rest? Am I going too slow? Okay, I'll just continue. Anything, just tell me. So now our game manager has the levels. There's this public value that keeps increasing. This level that keeps increasing. So now all we need to do is to make sure that any relevant object will have their values tweaked based on the current level of the game. So how do we get reference to this level. So in my slides on slide 43, there's this thing called singleton pattern. If you're not too familiar, it's a common way to handle managers. It's also found in other areas, not just game development, in some software. And in Unity, this is one of the few ways they show how to manage a single object, like a single master object in a sense. So the idea is that the first instance of the game manager will be the only instance in the game. And I'm using that instance, and you're able to reference the instance from anywhere. So that's the idea of this single pattern. The main thing is there can be only one game manager. So if we look at the code on slide 43, the idea is that we will have a sorry, my typos are there. Static reference to a game manager. We call it instance. Let's make it private. Now, when the game starts, we check whether the instance has been set. So if the instance has not been set, then we set ourselves as the first instance. And then we do nothing else. Otherwise, we destroy ourselves, which sounds kind of bad, but yeah. So the main thing is there can be only one. There can be only one instance, and this makes sure that when we call for that instance, we will always know that it's that same game manager logic that we are referring to, and that will be the same level that we are referencing. Now, the way we are going to get this instance from other places is using a getter. A getter is just another pattern where you only you only let them access this instance instead of directly accessing it if this were a public value. So we do this getter is a static method that will return a game manager, and it's called get instance, and we return the instance. Everyone can understand this so far? Okay, you see how it's being applied. So for example, as the level increases, right, what I want to do is, let's say I'm in level 2, now I want my speed to be faster. I'm level 3, I want it to be even faster. Level 4, I want it to be more and more faster, and this will be based on the level. And here at the start, when our bullet is first spawned, we'll set the speed, and then we'll do this. We call the class game manager dot, and since get instance is a static method, we can just call get instance, and this will return the game. Okay, let's just do like this. Yeah. So this will get the only instance of the game manager, the one game manager in our game. And wait, did I put this as private? Then the level is like this. Now we get the level, and now we update the speed based on the level. So we always start at level 1. So perhaps what we can do is, this can be anything as long as the speed increases with the level. So what I'll do here is I'll just take the level minus 1 times some multiplier, like maybe 2. So maybe let's put 1. So level 1, he will be his speed will be 1. Level 2, his speed will be 2. Level 3, his speed will be 3. So every level will increase the speed by 1. Basically, this is what this is doing. So let's see whether this works. Let's see if we can make the boot delay slower. Okay, let's put 2. This is fine. Hang on. Okay, let me reset up this thing. Let's watch the level here as well. Is it going faster? Can anyone tell? Maybe I'll just make it more obvious first. Maybe it's too obvious. So this is the normal speed. And then when the level changes to 2, it's a bit faster. Level 3. Okay, it's still not obvious, right? Okay. Let's put 6. Okay, so it's faster now. So as the level progresses, the speed will spawn with a faster speed. And so that's how we normally handle this. But let's put it do something reasonable first. At the same time, we also want to make the bullet spawn at a faster rate, right? So this is handled under the bullet spawner, and we just have to reduce the delay by a certain amount. So as the level increases, we want the delay to be smaller. So we can use inverse division, like this, and we do some shortcuts like instance dot. Right. So as the level increases, the delay will be divided by 1, divided by 2, divided by 3, divided by 4. And eventually, it will be so fast that there's no delay. But that will be like very far away. But let's see. Let's put this here. So as you notice now, the bullets are spawning at a faster rate. And as the level increases faster and faster, it gets more and more difficult. So then maybe let's try and play the game now and see whether it's a challenge. Okay. And then I'm bad. But you get the idea. So if this is a sort of a game design kind of idea where you want to make the game more challenging as you progress. It's rather natural to us, but when we're designing games, sometimes we forget. But in many games like Candy Crush or whatnot, you will see this kind of pattern where the longer you survive or the further you get in, difficulty increases. And then this is what makes games fun. It cannot be just like a breeze all the way, or it cannot be too difficult at the beginning. So that's why I think this is one of the more important parts of this workshop is that when you make a game, you must also consider not just the code but actually the gameplay. And these delays, right? All this logic for the delay and the speed, you have to do play testing to make sure that the difficulty curve is something that is not too like gentle, but also not too steep. So it's a lot of playtesting. Okay, what's next? Okay, the last thing I have planned right now is doing UI. So when you play the game, normally you want to see the text in front of you, right? For example, I want the level text to appear. So let's go and do that right now. The first thing I want you guys to do is create a new game object, but it's not an empty one this time. We're going to use UI, and we're going to look at text here. So this big thing, this canvas thing will appear. And if you zoom out, this is actually your screen, and this is your text. And wherever you position, okay, let me see. No, it's good. Oh, I should hide this, right? Okay, so notice that this is your screen, and if I move it here, look at how the text here, if you can see, the text will move. Let's make it more obvious. Oh, it's too big. Okay. Okay, I don't know how to do this. Anyway, so your text will be here at the bottom right hand corner of your screen. As your screen scales, it will the white canvas will change, so you need to plan accordingly. So all we got to do now is from the game manager, we just have to take this text and then we set the text to be whatever the level is currently. To do that, we need to get a reference to the text from the game manager, and like how we've been doing so far, we can just like make a public text and then level text like this. Now you'll see that there's this problem here where the type or namespace name text could not be found. The reason why this happens is because the Unity UI text is not in the namespace Unity engine. It's not available here. You need to go one level deeper, which is Unity engine UI. You are importing the UI, and now you are able to use the text. Okay, notice here is part of the UI namespace. So now you are able to able to use the text in your code. So now all we got to do is every time we change the level, we update the text accordingly. And also when we start, we update the text. So level text dot text equals to level. Let's do like this level. So there'll be a compilation error, right? Oh no, it's mine now. Okay. And we also do it every time we update the level. And all we got to do now is under the game manager, there will be this text, level text will appear. And then we just drag the text in. And we click play. Oh, we have the level over here, if you can see my slime. Okay. So well, this is pretty much what I've planned so far, but since we got a lot of time, let me try to show you how to do particle effects. But right now, Are there any questions regarding the project so far? Are you all okay? Okay. All right, then maybe I'll see whether I can show you some particle effects. So whenever your character dies, I want it to I want it like maybe a lot of green stuff come out. Oh, sounds good. Okay. So let me think where it should be. We do a hacky version first, okay? We do a hacky version. So we right click and then is there particle effects, particle system here. Don't put it under the game manager. Whoa, you see this? That's the particle system. Whoa. Oh, but it's very blur. And my first thing is to set the color to green, right? Because that's the slime thing. Then it doesn't work. Oh. I don't like this effect. So if I'm not wrong, we can change the type of effect we want to use using the renderer mesh. Then I think it'll be, this will be mesh. Are there other things you can use? Is there a circle? Where's my circle? Oh yeah, by the way, if there's an error for any sort of effect or particle, it will be this color. It's not intended. So if you ever see it, this purple color means something went wrong with your texture or your material. Wow, what's this? Okay. So I try to, normally you can set this. Since this is not done, please bear with me for a while I play around. In the meantime, if you all have any questions for the previous one, you can just let me know. Did this? No. Or maybe I don't have the. Okay, let's just use this. And then the size, spread, sphere, hemisphere, cone. What's this? Never seen this one. Okay, I think yeah, most of this stuff is you have to play around with the particle system. Let's set the duration to not looping. So you click. So every time you trigger the particle system, you spawn the particle system, it will spawn like this, which is kind of weird. But okay, I'll work with this first and get the particle system to spawn. So the idea is now when you hit the player, the bullet will spawn the remains of the slime. So over here under the bullet, we'll we take a reference to the, if I'm not wrong, it's game object particle. Wait, let me double check if I can do this like this. Okay. Remains. I call it remains. And then I'll spawn it. Every time if the collider is where instantiate remains at my current position. So transform is just saying my game objects transform but you don't need the game object in front. Transform dot position. Okay. Don't care about rotation. Okay, need to care about rotation. Okay. And now under the bullet logic, which is in the bullet prefab, we can now add the remains here. Okay, we can't. We have to do this again. I think we have to do this too. Yeah. I'm not sure if this will work though. Okay, let me go and Google. Uh-huh. Fine. Oh, I know why. I have to create a prefab, I think. So remains, call it remain. And I drag it here. So now this is a prefab, and I can drag a prefab into a prefab. I think that's how it works. Let me see whether it works. Oh, this. Let me give it this. Okay, I'm dodging. Then it gets too hard. Wait. Oh, so the slime died. So basically, what happened is the bullet hit your slime, then the bullet spawns the slime body in the form of a particle system, and that's how it works. So ideally, you wouldn't want the bullet to spawn the slime's body, because that's not the bullet's responsibility, right? Normally, you want the slime to be the one to explode, not the bullet exploding as the slime. So what we can do is perhaps we can create a different method for the player controller. So if I'm not wrong, we can, when the bullet hits the player, we search for the player controller, and then we call a method in the player controller. So let's define a method that we can call from the bullet. So destroy player, and then we spawn particle. Oh wait, yeah, with no return type. Spawn particles. And then we take the remains, put it into the player here. And then this logic, we move to the player, we move it to here, and we don't destroy the collider, we just destroy the game object. So now, if the collider tag is a player, we find the player controller game object. So collider dot and straight get component again. Right, let's do it. Game object dot get component player controller. So box collider on our player would ask the game object, which is the player game object, to find me the player controller. So once I found it, let's just make a quick reference here. Player C visual concept. Then from there, we do player C dot destroy player. So in a sense, next time, let's say I want to also play a sound in the player, we don't have to find everything that kills the player, right? All we got to do is go to the player and then we update this destroy player, because in some games we wouldn't want to some games you can have different ways to die, right? Like you can die from bullet, you can die from falling, but in the end you still want to destroy the player play and show the death animation. If let's say we do the logic of destroying the player in the different ways. For example, bullet, I destroy the player in one way, then maybe in a spike trap I destroy the player in another way. Then we have to edit both code to make sure that our new changes are made. By making sure that we call the destroy player, we can just make sure to only change one place. Every time we need to add a new thing, we only have to change this destroy player logic over here. So this is a good practice to do. So but I can say that, but make sure it works first. Under the player, we add the particle system. Over here. And oh, okay. So of course, this particle system you must tweak around to get the effect that you want. Let's see if I know any good things we can do. Okay, is there a speed? Speed. Okay. Okay. I guess you guys get the idea, right? So if you need to find out more about particle systems, you can go onto the Unity documentation or find more videos regarding this. I'm sorry, I'm not too expert at this, so at particle systems, so do forgive me. So right now, I also want to show you another feature of Unity that I found useful in my development for some of my modules. So in games, right, one thing that is very important when you have a lot of things going on is optimization, right? In many games, you'll see, wow, very laggy. The reason why is because sometimes you're spawning a lot of bullets. Sometimes you're calling a function too many times. Sometimes you're just drawing too many stuff on the screen. So there's this cool inbuilt feature in Unity that may be useful for some of your development. Under the window, there's this profiler over here. Oh, the profiler will actually let you know everything that's happening in the game. So if I inspect with a deep profile, oh my gosh, okay, you can see like where the spikes in your FPS are. So for example, yeah, it's pretty good. So notice the first thing over here is like 83% of your process. But this is just editor overhead, meaning that when you build the game, it's not going to matter. So all you have to care is everything after this or anything that's not the editor overhead. So right now, this may look like quite crazy, but let me show you an example. And I'm going to write a very bad script, and let's see if it works. So like slow, I call it slow. Okay, this game object, and I'll create a new script. Oh, by the way, you can make a new script from this add component here, and we can call it slow and add. and you can open the script from here, right? Okay, never mind. So what I want to do is just every frame I do a for loop 1 million times. I think that sounds good. Nine. This is fine. Oh, it's out of range. So yeah, I think this will crash, but let's try. So okay, so so what's happening is I'm printing out slow. I don't know how many times. Oh, this should be a semicolon. And let's see whether our game crashes. If it doesn't, then we can profile it and see whether it picks up. So I think this was a mistake. Oh, I think I destroyed your computer. Unity died. Okay. Oh, do you notice I didn't save this, by the way? If this is a star here, it means I didn't save, and there's no scene, so I have to restart from the beginning if this failed. But that's just life, I guess. But don't worry. All this stuff I'm gonna upload onto GitHub on this machine. I've done it on this machine. So if we ever need to refer to something, I will have it uploaded. I'll share with you all on GitHub. This is a tragedy. We have to restart. No choice. It's gone. No, it's gonna crash. This is what I did.
What did you do? Oh, what is this? Oh.
Okay, never mind. We'll continue. Just restart it. Okay. The rest doesn't matter anymore.
You want to restart everything from scratch?
No, I'm not going to do anything. I can hear your computer working very hard. Anyway, if you guys have any questions regarding your game, you can always approach me now, or during on Slack you can try to ping me and ask me anything about development, and we'll try to answer. I'm also trying to invite new people, our exco members from game development group. So game development group is NUSGG is game development group, and we hold weekly sessions every Thursday for those who are interested in game development. Also, at the end of this year, let me go to the slide. At the end of this year, there'll be this thing called GameCraft 2018. So it's a 24-hour game jam that where you form a team of maybe around 6 people and you try to make a game within 24 hours. And at the end, there'll be judging by industry professionals, and those the win will be awarded some prizes. So do take note, we'll be informing probably the cohort and other faculties as well regarding the sign-ups for this event. So just take note. Our game development workshop is every Thursday, 6 to 8:30 p.m. Normally the venue will be at AS8, and this is during the semester, so not during summer period. So when the new academic year starts, our first session will be on a Thursday, and it will always be at that timing. So just keep a lookout. We also have a Facebook group. So this is our Facebook group, and no. So let me showcase some of the things we have done. So this is this is one of the projects that we have worked on with the new year ones. The idea is that us as GDG, we create this dungeon, boss, and as the new year one, what you do is you create this yellow box, and then you pimp it out and then make it a character that you want to play. And in the end, at the end of the semester, we want to have a co-op dungeon run for all the teams. Yeah, that's what happened for this year. For next year, most likely, we're not going to be carrying on with this project. But if you're interested, just let us know if you want to work on something related to this. But I don't think we have any plans for it right now. Yeah. Okay, let's see what other slides. Okay, by the way, there are other areas to explore in Unity. Particle systems is one of them, although I didn't do it justice. There's a lot of particles effects that you can do with Unity. Later I'll show you a game that I made for a module, and it really uses a lot of these particle effects, audio, post-processing, not multiplayer, profiling I use quite a bit, and scriptable objects. There are also other useful resources like this. These two channels over here, Sebastian Luck and Brekkies, they have a lot of very good content for Unity, specific to Unity. So for Sebastian Luck, one of the good tutorials I learned was to create a 2D platformer from scratch. So I'm not using Unity physics. We're just using a pure raycast. If you're not sure what raycast is, you can go and check it out, or you can ask me later. And for Brekkies, he's always sharing the new things in Unity and all the things like machine learning or maybe navigation meshes, stuff like that. So you also can check it out. And his videos are really well made, and he's a good speaker. So pretty good. For general GDC, GDC is like it's a place where they have a lot of talk about anything related to games, and you can get a lot of inspiration for the game that you want to make. Maybe not for Orbital, but maybe in the future. But you can take some of the key ideas presented in GDC and make it your own, or add it into your game. And lastly, I know some of you are not really artists, so there are some links to free assets that you can use. One of them is itch.io, so let me just show you. And I'll load the other one as well. So itch.io has a lot of assets over here. Some have to be paid, but I think the free ones are pretty good. So you can just use these assets in your games, but make sure to read the disclaimer. Maybe some of them say you cannot make a profit from using the assets. Just take a note of that. Also, Kenny is another good place to find free game assets. Oh yeah, tips to survive Orbital. So like I also did Orbital, but it wasn't a game. It was some small application. For Orbital, what you should try to do is set realistic goals, right? Game development is very time consuming. I think I would say that 40% is actually making the game, and 60% is polishing. Okay, the number I just pulled out from nowhere, but just the idea is that you need to do a lot of polishing. You can make the base game, I would say, rather fast if you know what you're doing. But to make it something that people want to play, you need a lot of play testing, a lot of polishing, and a lot of this thing called juice. Maybe if you have time, I'll show you the video about juice, or I'll share it with you. Sorry, give me a moment. Okay. So by setting realistic goals, right, what you should do is focus on one core mechanic or a few core mechanics. If you want to make, let's say you want to make a fighting game, make sure that the fighting is fun. Don't go over the top like cutscene animation for your super effects. Make sure that when a person punches another person, it feels good for the the person punching, things like that. Or in Mario, let's say in Mario, the button that you use the most is the jump key, right? So make sure that the jumping is good, and this will really help this will actually make or break your game in most cases. The third point, learning how to use Git. Anyone not familiar with Git? Not familiar with Git? Or anyone use Git for your? Have you used Git before with Unity? Because using Git with Unity is a bit different. There are some pointers to know. So the first thing is to learn how to set up. If set up Git, there's this quick link, and I'll just run through it like briefly. So blah 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 here. Make sure your project settings are set up correctly. Use this Git large file storage, Git LFS, to save binaries. And there's another tip is that when you're working in with Git, right, make sure that the thing that has the most conflicts, right, is your scene, the .scene file. Okay, let me see if I can retrieve the dead game. How do I open Unity? Just now I didn't save the scene, so but the key thing is, yeah, see, this wasn't saved, which is a tragedy. But this thing, right, is actually your game. When you build, right, it will play this scene. So when you are two people working on one scene, and you try to commit and you try to merge them, right, it's very likely there'll be a merge conflict. So let's say you're doing a small feature for maybe perhaps I want to do a different bullet spawner. What you should try to do, or a good rule of thumb, is create a new scene and work on that one. The idea is that no two people should be working on the same scene at any given point of time, unless you are going to later to the date, and then you can somehow resolve the conflicts easily. But just a rule of thumb, don't work on the same scene. Yeah. Are you aware of like the Git, how Git works? Like merging, branching, stuff like that. Yeah. So if you branch out and then you all work on the same scene and you merge back in, it's like the merge conflict is not like those, in your code there will be the lines where, or in this part there was this line written, but then you wrote this line. Let me see if I can show you. This is something like this, and like, yeah, have you all seen this kind of thing? Yeah. If you haven't, you will see it pretty soon. But for the scene file, right, you have to actually. Okay, this is safe, right? This .unity you can open with code, and then you'll see that this thing there, and then you'll be like, what does this all mean? So to be safe, try to work on scenes separately. If you do encounter a merge conflict on the scene, on this scene, right? Most likely, what I recommend to do is you just use one guy's scene, and then you work out putting the changes onto the other scene. If you all understand what I'm saying, you understand? Like, just don't care about the other guy. Just use one guy's first. Then we do some damage control at the end and get the other guy's stuff back in. Right? Just one tip that I have. Okay. As of now, I don't have much. Maybe I'll show you the game that I made, and I'll show you the different things to achieve what we did. Right? So this open a new one. Oh, okay. I'll go to the GitHub. Okay, never mind. I think we're not famous enough. It's okay. Don't worry. It's like that. It's like that. Yeah, not famous enough. I'll search for my name. Oh, I think I can search it like this. No. How do I go to users? Hey, don't look at my face, please. Oh yeah, there's no link to the YouTube. What am I doing? Oh, these are my Overwatch stuff. Oh, who plays Overwatch, by the way? Anyone? No. Oh, was it removed? Okay, I think it got removed. Steps. The tragedy. But anyway, so let me show you like some early pictures of the development. I think some of you have concerns about what you should be doing at the start, like at this point in time, what do you need to do? So don't be discouraged if your game looks like crap at the beginning. So if I'm not wrong, oh yeah, I think it's also good to do your project on GitHub and post issues of the problems is to keep track of whatever you have done wrong. Maybe, well, I can't remember all this. Let me find the pull request. Is this? Yeah, I think I just try to show you our early levels. Okay. This had a lot of. So basically, our game looked like this at the beginning. It's just like random squares around, and yeah, it looks really bad. And then just then we comment and he's crying because so many comments and then stuff like this. So the idea is what you should do is just start small first. Like our end goal for the game, right, was to actually have this times 10, like one whole sequence of this but at the beginning what you should be focusing on is just making like the first few stages or just one chunk at a time. So if you are going for something very big, I would suggest you just do a demo for Orbital. So like this is our idea and we want to do we these are the mechanics of the game, and then probably at the end of the first half of your game then to be continued, something like that will be sufficient. Don't go for something too big like you want to make the next Overwatch or the next Dota. No, not possible. I just let you all know. Yeah, I'm sure you all know as well. So it's I think the biggest concern is whether you can finish your project in time, right? So the thing is I think you shouldn't worry too much about it now because right now you're just learning Unity. What I suggest you all to do first is to do some simple mini games like that slime thing I just showed you all. Can be done quite fast, but you need to know how to work your way around Unity if you're using Unity. If you're using something else, then you should try to make small projects with that. But uh, then again, don't overdo it and like do multiple game jams. You still need to enjoy your summer, right? So it's a balance there. So take some time to understand the engine a bit. Then after that, you can have a better gauge of what you can do within the next 3 months. When you actually start doing your game, we need to make sure what kind of design you want to do, what kind of game you want to make, right? And during this time, I suggest you all make a design document. So like the document would be something along the lines of what is this game? What are the key mechanics in the game? What are the controls? Is there any story in the game? So maybe I have an example. Is it this? We store our like other stuff here. I'm trying to find the Google document. Okay, but basically we had a Google document which stated like, hi, this is our game. We set a deadline for ourselves, and then okay, it's here. By the way, this is another Orbital project. This legit. Okay, so we had a deadline something like this, and then so we make sure that we have something done by every week. So do weekly milestones. So like, oh, by this point in time, we want the block system to be done. By this time, we want this to be done. And then by a certain period of time, we want the game to be playable so that we can perhaps send to people for playtesting. I'm sure like Orbital has some milestones, right? You have to meet 1, 2, and 3, something like that. So maybe try to get a prototype by milestone 1. So you make sure that by then you do the necessary steps to get something playable. Doesn't have to be like a full level, but just the core mechanic of your game. Then the questions you want to ask is, does this game feel fun to play, or does the movement feel good? Does the aiming feel right? Does the transition look good? The things that are related to the core mechanic of your game, make sure you get it play tested as soon as possible. Like for example, the game that we made, okay, there's no video again. Okay, never mind. Oh, so this is the Google Doc I was talking about as well. So we at the very beginning, what are the rules? We decide what is the theme. So anytime in doubt, we always refer back to this design document, and we talk about story, aesthetics, what kind of look we want our game to have, mechanics. So what's the goal of our game? What kind of gameplay we want to achieve? Dynamics. Okay, but some things the naming is not important. Just knowing what you want to do is more important, right? Technology, ignore this. Yeah, then we just wrote stuff like to make sure that we are all on the same page. This is more relevant for groups with a lot of members. Sometimes you think he said this, then he said that, then who is right, right? Then just make a document, refer to it, and then that's it. Yep. But if you are a two-man team, a two-person team rather, you should be quite okay. And just make sure. I think the most important for Orbital is this deadline thing. Having a deadline will make sure that you get things on track. So and you're focused down on the individual stuff. Yeah. Or you can just relax for this Orbital. It's also okay. If you want this repository, you can search here. This was written in Unity, so if you all need like anything, you can refer to this. We use one library that we use is this thing called oops. So let's see Brachis. Brachis got any good content? What's this? Oh, it's not Brachis. Hi guys, blah blah blah. So then he'll talk about post-processing and how you can change the effects, things like that. Let me see if I can find the YouTube video. Ah, okay. Yeah, I know how to find my game now. Okay, so this was our game at the very end. So if you notice, right, like, okay, is there music? It's fine. So let me show you what are particle effects. Okay. Oh, okay. So if you notice, right, like, okay, let's turn off the sound. Thanks.
Okay, the sound.
No, it's okay. It's okay. It's okay. It's not important.
Mute this.
Ah.
Okay.
Okay, wait. We just missed the particle. Okay. So this is a particle over here. When you move the block, right, I do the exact same thing that I just showed you, but then the particle system, right, you have to tweak accordingly to achieve this loop. So if I'm not wrong, we use some mesh instead of the, this time what I use some sprite for the particle effect. And then when he jumps, okay, look, there's another particle effect. Also note, right, when he walks into it, it's the same thing as the bullet going into it, right? It's the same idea. This gem has a collider. You walk into the collider, it explodes. It's the same thing. So all these small ideas you can build into something that looks like this. It's exactly the same. And then, yeah, more stuff. Let's see. This being destroyed, destroy game object, same thing, same idea. Translate game object, same thing. You can make my game, it's okay. My team's game, right? We didn't do jumping. I think jumping is a bit tough. Translate, yes. What other things that you can do? That was the material. We changed the material of the thing. To make it glow is like adding a light to the object. Maybe I can show you later. Oh, let's see. What other things? Okay, that's it. Don't see the rest. The ending is buggy. So for example, I was talking about that glowy thing, right? You just need to know that such things exist, right? So you just play around. You right click. Oh, light. Okay, let's try light, directional light. Oh, okay. Then you just keep adding stuff like. So for the other thing, I think we use the point light. I'm not sure whether this will look nice. Oh yeah, it won't look nice because the lighting is not set up in the game. But the idea is that you just add the game object and it will add stuff. And then you just have to play around, things like that. Yep. Yeah. Any questions regarding life? Yeah, you can go to, if you want to look at the game development module projects for inspiration, you can go to steps. Okay, what's this? Okay, hang on. NUS. No, okay, this one. So you can go to the modules, and then you can see all the other games. So Ryan's game, just now Ryan, he was doing the physical workshop. He made this game which won. Oh, what was that song? Huh? Dropbox. So this Ryan's game. Ryan did a VR game for steps. So the idea is a bullet hell. See, spawn bullet, same thing, and then yeah, when the bullet hits your collider, you lose health or you lose points. Basically, this is what game development is. You just take the different ideas and you combine into something like this. And notice how like actually the game looks really good is because there's this idea called juice in game where you do a lot of small little details that make the game look really nice and polished. So for example, see like this kind of thing is actually just they could have just make it a one line thing, right? But they made it multiple lines. So you see like even though it's one line, right? They added the effect of multiple lines. So something like this will really make or break your game. It's like it looks way cooler basically. If you're thinking of what you should do, you just think what looks cool. Or you go and look at other games, like for example Hearthstone, right? If you all are familiar, if you open a pack in Hearthstone, it will boom explode, right? So this kind of things, you don't have, it doesn't need to be there, right? But it really make or break your experience. So, but this kind of thing you should put at the end of the development, where you already have a game. People think that the core mechanic is good, so all you need to do now is just add fancy stuff, and these kind of fancy stuff are actually very fast to make. So towards the end, where you like, oh, I want to make my game better, but I don't have time to add new features. You just add like small little details, like when I jump, then there's a sound point. These are all the small little things you can add. Yep. But is there like an Orbital website? What Skynet? That thing? Yeah, are there like shows for other games, previous Orbital? I think they showed you all the hero for hire. Is it called hero? Hero as a hobby, right? During Orbital liftoff or something. Right. I'll just find YouTube. I think I know where it is. Oh, yeah. Youth. Yes. Oh, by the way, the workshop is over. If you all like want to listen to me talk, you all can go. It's okay. I know this the previous. Or if you want to ask questions, just like either approach me or like come down, or just speak your mind. No, there's a previous video. Wait, is everyone from SOC or not? Or everyone's from SOC? Or SOC? Not SOC? Oh, it's okay. I mean, it's good that you do Orbital because it's a good experience. Like I also did Orbital, and you will learn a lot, not just about like about coding or computer science. You learn stuff like project, how to manage your project, and staying motivated. I think like the second month or the third month, I was like, should I continue this? It looks pretty okay, but in the end, you should look forward to Splashdown, where you will showcase your games. I think you'll be briefed on it later. And during that time, I have some like tips for you guys. In Splashdown, what you should do is try to promote your game if you want, and maybe do some publicity. Because if I'm not wrong, the team that won the Apollo last year, they handed out the flyers to people to vote for them, so they won. Because when you vote, you only vote by the number, right? So they just see the flyer, oh, this number, then they just put first place. Okay, so hope you all can find that strategy useful. Oh yeah, maybe I can do the profiling now, if you all are willing to look at it. So the slow is still here, right? But yeah, let's not do so much. I think 1000 is enough to let the system. Oh, goodbye. It's raining. Oh no. Okay, it's printing a lot of lines. And then notice, right, if you want to check the FPS of your game, you go to the top right hand corner of your game view. This is the scene, this is your game. Top right hand corner stats. You can see your FPS. My FPS right now is 2 because I'm printing 1000 lines per second. think you're wondering, oh, the computer is heating up. So if you are wondering why is my FPS 2, then okay, time to open your profiler, right? So where's my profiler? Yeah. Okay. Hopefully the profiler doesn't crash the thing. I think the profiler will crash it though, because the profiler adds additional load to the process. So let's try again. I'll open up the game stats. Oh, okay. You can see this thing. It's just a graph of your FPS, and it's not looking good. So we can pause time and see at this moment where the FPS was high. So in this case, it's everywhere lah. What is the one? Oh, 90.6. Remember last time our editor overhead was like 80%. Now this process is taking 90% of our CPU. And what is it? It's in this behavior update. So it's in the update call, and slow the update. Oh, I wonder what's causing it. It's logging string to console, 89.4%. So there you have it. Don't remove the print statement. If you remove the print statement, I think it'll be faster. So let me try. Okay, wait for it to compile. Play. Oh shit. What happened? Look, my FPS is fine now. My FPS is 70. So just a side learning point is printing to console is actually quite expensive. So do it sparingly. And if you like suddenly see your game not working because you are printing in some for loop, just take note. Console statement is like printing to the console is expensive. So yeah, take note. But it's still, this is still pretty bad. 76 FPS. So if you want, you can just not do this every update. The things to, oh, maybe another point. You know how I show you all get component, right? Get component, sprite renderer, things like that. Do this only in your start, because this is actually quite expensive operation. So don't do it. Try not to do this in your update, right? So don't do it every frame, basically. If you want to do this, make sure you do it sparingly, right? So normally that's why we have references to and we will have a reference like this, sprite, then we'll do it in the start. So it's called only once. Okay. Yeah, do it once, then you'll never have to call it again. And yeah, another tip for optimization. But just yeah. Anything any topic you guys want me to talk about before it's 3?